Hey guys, welcome. There's a whopping two of you right now. That's great. Off to a great start. Um, Basically, what I want to do with this stream is explore what we can do together collaboratively while making something pretty cool. Basically, the point is we'll start off bare bones C++. We'll add some OpenGL, some GLFW. Those are some frameworks that help us with the graphics, with the events, with the windowing, all sorts of stuff, input handling as well. And that is basically where we're going to do most of our work, at least at the beginning. I don't really have a set plan, like a set end goal. We're kind of just gonna go with the flow and create something together. That's the plan. And really, the way I want to structure this in terms of code is to maintain the engine side of things separate from the game side of things. So we wanna design this in such a way that the engine doesn't rely on game, and obviously the game will actually rely on the engine, but the engine should be its own thing that knows nothing about our game, and our game provides the engine with the necessary um, data and everything else that allows our game to actually do what we want it to do. So that being said, we can go ahead and start. So if you guys want to follow along, that'd be great. What I plan on doing as well is after every stream, wherever we left off, I'll push that to GitHub, and I'll put the link for GitHub up in my channel at the bottom there, so that we can, newcomers and everything can just pull the latest code and start, where we left off together. I also plan on putting these streams up on YouTube so that anybody that's coming in later on will be able to catch up and then continue to follow us as we go through this together. All right, so let's go ahead and start. So we're going to open up Visual Studio. I'm using Community 2015. It's free. If you don't have it, go ahead and download it. It's awesome, and it's a very powerful tool that we're going to be able to use here. So we'll create a new project, and we're going to want to see Visual C++ project Win32 console application. So definitely bare bones, and we're going to call it Twitch. We'll hit OK. And this is important, so we'll go next, and we'll make sure we tag empty project. We don't want Visual Studio to do anything for us. We're going to start from scratch. So we'll go empty project and hit finish. And there we go. Okay, so a totally empty project. We're ready to go. So one thing that I like to do personally is right here on the side, Visual Studio shows you the header files, resource files, and source files. That's actually it grouping certain files based on their file extensions together. It doesn't actually mean that this represents what's actually in the Explorer, basically. So what I like to do is tick this guy here, show all files, and this is what we actually look like in Explorer. So this is the real structure of our program and of our game, basically. So this is I like to leave this on so that I'm aware of exactly what the whole thing looks like in my project. So we'll right-click Twitch, and the first thing we're going to do is add a new item, and we will add twitch.cpp. All right, and there we go, fresh page. So just to make sure we're all set up properly, what I'm going to do is just do a simple hello world. So we'll go iostream, and I am assuming you guys have some C++ experience. If there's anything you don't understand, just let me know in the chat. I'll check it periodically, and I'll explain whatever you guys need me to explain. So iostream, and then we'll start off with hello Twitch, and then we'll do a system pause so we can actually see our message there, and we'll return 0 at the end. So if we run this, very simple. We know that we have a bare bones project, and there it is, hello Twitch. Press any key to continue. And that's what pause does. Okay, great. So, okay, we have a basic C++ program. Now, basically the start of what we want to do is set up the engine that we're going to be using, that we're going to be creating for this game. Over here, again, I want to add a folder, and I'm going to call it engine. And the idea here is, again, to keep the engine code separate from the game code. So within the engine folder, I'll add a new item, and we'll just call this guy engine.cpp, and we'll add a header for that guy as well, engine.h. There we go. Now, one thing that Visual Studio likes to do for you is add pragma once comments, or these lines here that basically ensure that header files don't get included multiple times, basically. So there's no duplicates. Pragma once is a Windows thing, and I like to be a little better than that and not explicitly do this for Windows. So the equivalent, basically platform independent equivalent of this is so you basically you check if something is not defined, and if it's not, then you go ahead and define it right away in the next line. So we'll say if not defined, we'll call it Twitch_engine, then we'll define it here, and then we'll end it here. So basically what this is going to do is if somebody else includes engine.h, the first time, this won't be defined, so then we'll actually go ahead and define it, and then the next time and every time after that, this will be defined, so none of this will actually go through. Well, this if block is going to return false, and none of this inside is going to execute. So this way we ensure that it only happens once. And here we can start the engine class. We'll have a public and a private. So the goal here is basically to set up OpenGL, GLFW, and just get a screen going. So what we need to do is actually include these frameworks in our project. So what I'm going to do is go to Twitch, right-click, and this is the project itself, not the solution, and we'll manage NuGet packages. I'm going to use NuGet to help us out here. So we're going to browse for, it's called OpenGL. Now this is NuGet OpenGL. It's a combination of the two, and this is what we want here, OpenGL.core. We're going to go ahead and install that, and you might get a pop-up here. Just hit accept, and you'll see down here that it's finished and it's successfully installed OpenGL to our project here. So now you'll see this packages config, and it shows you basically the packages that we've downloaded from NuGet, and this is what's available to us now. So right away, using this, I'm able to go ahead and go back into engine.h, and we can include basically our GLFW right in here. Now, since everything is going to be running through the engine, it makes sense to include GLFW here, and this is basically the root of our engine, which is going to set everything up for us. So we'll go ahead and include it, and as you can see, you'll have GLFW available to you now, and GLFW3 is what we want here. So by including that, we are already set up to use GLFW. Now we also have to link it. Now this is where I'll use pragma comments. Now I know I literally just said I like being platform independent, and that's why you did these up here. Pragma comments are just a little easier to set up in code. I could go into project, properties, and then VC++ directories and add the library here. But I'm just going to do it this way for simplicity's sake here. So we'll go lib, and what we want to actually link to is called OpenGL32.lib. And if you notice, GLFW3 uses OpenGL 32-bit, so we have to make sure that our project is set up for 32-bit up here. So if it's set to 64-bit, you're going to have DLL issues, and it's not going to be able to find the right library, which means you're going to get linker errors, and that's a whole mess. So OpenGL is 32-bit. That's what we're getting. So we have to write this for 32-bit. So once we've got that, we're basically including what we need, and we're linking the library that we need. So we're actually able to go ahead and start doing stuff with OpenGL. So what I'm going to do here is add a couple of things. So a couple of things that I want to keep track of that are pertain to the engine itself, and by way of providing this data to the engine, we'll be able to provide it to GLFW, because our engine is what's going to deal with GLFW directly. So I'll create a static int here, and it will be public. We'll call it screen width, and this will just hold obviously your screen width, and then a static int screen height. We'll have those two, and we'll go ahead and actually create our constructor, our deconstructor, and we'll create a function. So basically the way I want to do this is not to initialize the engine as soon as we create it. We'll have an initialize method that will actually handle that for us, so that we can create the engine object and not necessarily initialize it right away, just to be flexible there. So we'll have an initialize method, and we'll another piece of information that we need is the title that we're going to give our window, because this is just a window that's going to show up. So we want to give it a title, and we can track that with just a simple char star. We'll call it window title. And actually, let's make this return a bool, so we can check on the other side if we actually successfully initialized anything or not. Okay, so we have two static ints, constructor, deconstructor, and initialize. So now that our header is set up, let's go to our CPP. And obviously the first thing we want to do in our CPP is include our header. So we'll include engine.h. And then we have static ints, so we have to declare them right now. It's int, and it's engine screen width. And we'll set that equal to, let's do 1024 by engine screen height 768. I think that's right, 768. Okay, and then we'll start with our constructor, which right now we don't want to do anything because again we want our actual initialization of GLFW to happen in the initialize method. So engine deconstructor. Oops. Again, same deal. We don't need anything in there yet. And then we'll create our bool initialize method that takes a char star window title. Okay, now here's where we get into like straight up GLFW code that we kind of just need to do. A lot of OpenGL setup code is you kind of just memorize what you need to write and then you just write that every time. Everything does have a particular purpose. I'm not really gonna get into the core OpenGL concepts. We're basically just gonna set up a context that we can use for our 2D game. So the first thing we want to do is initialize GLFW. So GLFW init, and because we included a header, we're able to just call these functions. And as you can see, it returns an int there. And the int lets us know if it's GL true, it's successful, and if it's GL false, it's an error. So we can go ahead and check against that. So if, and GL false just happens to be false as well, so we can actually just check it like this. And this is basically saying if it's false, then we'll spit out an error. And we actually need to include IOStream up here as well, because we're going to use it. IOStream. And then we'll go using namespace std. That's just so we don't have to call like std cout like that. We just use the namespace directly. So we've got that. Okay, so now we can go ahead and cout, and we'll cout error initializing GLFW. And then we'll just go ahead and return false here. Some people like to save a return value and return it always at the end. I'm just going to return false here. It's pretty straightforward. So now that we have that, we have to actually keep track of a window object. And this is like a GLFW thing that we keep track of. So let's go back to our header, and we'll keep track of that, obviously, as a private member variable. And this window is going to be, now since we only need one, we can make it static so that we can access it. So we can go static GLFW window. Yep, there it is, GLFW window. And we'll want a pointer to window. We'll just call it window. It's a pointer to a GLFW window called window, and it's static. So when we go back here, actually, so if it's static, we got to set it up here. So we can just do that by just saying GLFW window pointer engine window equals null for now. Since it's a pointer, we can just set it equal to null until we actually want to do something with it. So down here, we want to create our window, and GLFW has a very simple method for us to use. So we'll go window equals, and I think it's GLFW create window. There it is. Okay, so it takes a width, a height, a title, a monitor, and a share. So the width, we have it in screen width. The height, we have it in screen height. The title, we've passed it in as window title, and it is a char star as well, so that should be fine. And the other two, monitor and share, we don't care about, so we'll go null and null. Again, they're just pointers to other windows, so we don't need that. Okay, so now we've got our window. Well, we may have our window. We want to check now if that was successful. So if window is null, then something went wrong. So let's go error creating window and return false again. Okay, so basically if we're at this point in the code, we have initialized GLFW and created our window properly. So now we can actually start setting up OpenGL. So this is where basically our OpenGL set up. And this is where we get into kind of the lower level OpenGL stuff. But it's not that bad. So the first thing we want to do is basically OpenGL has a context of something called a context. And the context, we set it basically to our current window so that any things we do after that are just going to occur in our window. So that's why window is a pointer to a GLFW window so that we can pass it through, and then OpenGL can just deal with it directly while modifying our actual variable here. So the first thing we want to do is GLFW make make context current. So the current context is going to be a pointer to our current window. So there's a separation between the screen width and height and the window width and height, or well, the frame buffer width and height really. And that's basically where OpenGL is going to be rendering everything to. So what we want to do is create these width, height local variables, and then we'll get the frame buffer size that GLFW reads from the window we just passed it. And hopefully they match, and they should. But this is just to be safe. So GLFW get frame buffer size, there it is, and it takes our window, and it takes pointers to two integers, width and height. So we'll pass in references to our width and reference to our height, like that. And now after this call, because it took pointers to these variables and we passed in references, whatever this does to these two variables will actually see reflected back here. So width and height now should have some sort of value. So we got the size, and now we also want to set up GLFW swap interval. And this is basically, so there's a context, or so there's an idea in GLFW called basically double buffering. And the idea is that you have two buffers that you draw to. The one is whatever is currently being shown, and the other one, it's called the back buffer. And basically all of your draw calls happen on the back buffer, and when you're done drawing, you call swap buffers, and it's going to swap the buffer. So the back buffer becomes the front buffer, meaning becomes whatever the user sees, and then we draw on the other buffer that just went into the back. And without this, you tend to see a lot of flickering, because you can kind of pick up, basically as we're drawing things on the screen, you can see that happen, and it's very fast, which is why you don't really notice it. You just notice flickering. So this is why we want to set up the swap interval, and we basically want to say swap it every frame. Swap interval, we set it to 1. And then we have our mode, our video mode. So we have this const GLFW vid mode. Here we go. And this is, we want to pointer to this called mode. And this will be equal to whatever this function returns. And it's GLFW get video mode. And we get the video mode from a monitor, and this is going to be our primary monitor. So GLFW get primary monitor, yeah, it has that for you, which is awesome. And now our mode pointer, or GLFW vid mode pointer called mode, points to whatever the vid mode is for our primary monitor. And using this, we can basically say, this is basically allows us to get a context of our actual monitor, meaning our width and height, or screen width and screen height, all that stuff. So what we can do with that is set the window so that it's always centered on our monitor itself. So using that, we'll start. We'll just do this xpos. We'll set it equal to so mode has, again, our monitor data. So if we say mode dash arrow width, because it's a pointer, we use dash arrow, we can get the width of the monitor, and then we can subtract the screen width from that, and then divide that by 2, so that we get the difference. So we get the difference of how wide our screen is and how wide our monitor is divided by 2, and that'll give us the center point halfway down. And then we'll do int ypos equals mode height minus screen height. Oops, this should have been screen width. There we go. Screen height divided by 2. So same idea. And now we can do GLFW set window pause. Pause. There we go. And we can say set the window pause to, and then again take our window and set it to xpause and ypause. Okay. Now that's pretty much it in terms of the OpenGL setup, or at least the GLFW setup. Really, this is all GLFW setup. Now we can get into the actual GL setup. This is really where the real bare bones GL setup happens. And what we want to do first is set up our viewport. So viewport, and we are actually going to be calling base GL functions here now. So we're going to call it GL viewport. There we go. It takes a function, x, y, width, and height. Okay. Now remember, those width and heights that we got from up here from our frame buffer size, that's what we're going to use to set up our viewport. And this is how OpenGL is going to be able to use our actual window size and use that as viewport size as well. So what we want to do is, now you can set up the viewport any way you want. Like you can have 0, 0 be top left, top right, whatever, right? What I like to do is set it up like this, so 0, 0, and set the width to that width that we got from up top here, so the width of our monitor, or sorry, of our frame buffer based on our window. So width and then height. Okay. I'm going to set that up, and then now we're going to set up the GL matrix mode. Now this is basically how matrices are handled, or how the viewport is handled in terms of the matrices it deals with. And right now, for 2D, GL_projection will work for us. Now we can also do, there's a couple other ones we can use here, like GL_, see if I can remember what the other ones are. I actually can't. See if we can find something here. Yeah, there's just so many GL things, right? Projection is really what I've always used, so let's just stick to that. And this is how our 2D project will be set up. There are other ones you can use, and you can look into basically the GL wiki and find out what they do. But GL projection will work for us. Now that we've set up our matrix mode, we want to actually refresh all of the matrices in terms of like the camera position and what it's gonna render things like. And we can do that by doing GL load identity. And this basically loads what's called an identity matrix, which is basically the blank matrix you start with before you start rotating camera and all things like that. So we'll set up the load. We'll set up the new matrix, just GL load identity, just replace everything that's there with an empty or a starting really identity matrix. And from there we can set up our ortho. Now ortho this is how we can set up what's 0, 0, top left, top right, bottom left, bottom right. So if we do the left, we want that to be 0, and the right, we want it to be our width. Again, we're using the same values from our viewport here. So the right will be the width. The bottom, again, will be 0, because I want 0, 0 at the bottom left. And the top will be our height. So as y increases, that moves up along the screen. As x increases, that moves to the right across the screen. And then near and far, that's basically, we're in 2D, so it's not a big deal. But it's basically the range of depth that your camera has. And here we're going to set it up near, we'll just do -10, and far we'll do 10. And then sometimes in 2D, we can use this to layer our assets differently. So we can do that. And that's pretty much it in terms of setting up our basically our camera. Now we have to let GL know about our depth range. Which again, as we just wrote up top, the near is -10 and the far is 10. And we have to, now that we've set up our orthographic camera, that's what this projection was for. So GL projection sets up our orthographic camera, or sets us up so that the following GL calls we make are based on that projection matrix, which is dealing with the camera. And now we can set ourselves up for GL matrix mode. And then we'll do a GL model view. And this is how we're going to load our 2D assets and everything. Now, OpenGL is a state machine, really. So as you call functions, it changes the way the state of OpenGL at that point in time. So any functions we call after that are all related to based on the current state. So by setting the matrix mode here, these functions will act with our matrix mode set to GL projection. And now we can change our matrix mode, and any functions that we write after that will actually use this matrix mode instead. It just uses the current state of GL. Now, one last thing we need to do, now that we've set up our viewport, we also need to allow for what's called alpha blending. And this is what allows us to use PNGs with transparency in them so that we can actually load transparent assets and not have them show up as black or that pink color or whatever that may be. So for this, we enable a couple things. So we'll just do alpha blending. We'll do GL enable, and we're going to enable what's called GL_alpha_test. Enable the alpha test, and then we'll enable GL_blend, which blends things. And then the function we're going to use, blend func. The blending function we're going to use is you take GL source alpha and GL1 minus source alpha. This guy. Now, this is basically how alpha is going to be handled. So we enable blending, and the function I'm going to use for blending is the source alpha and then 1 minus the source alpha. And this is just how I've gotten it to work in the past. Again, if you want to look at how these things actually work, take a look at the wiki, take a look at documentation online. And basically, we're done with our GLFW setup. So I know all of this was kind of a lot of stuff, but we're really okay to go now. So now that we're done, we can actually go ahead and return true, and we'll actually know that our initialize method worked, and we're returning true there. So there's two more things really we want to do. We initialize everything, so everything's set up. Now we need, and this is pretty basic in terms of game development, we have two different functions. We have an update function, and we have a render function, okay? So these basically are things that happen technically, usually in that order. You update everything, you update the state of everything in your game, and then you render that current state to the screen. So we need to implement these two, and then we can actually see something. So we're here, so we can go ahead and do void engine, and we call that update. And update is, for now, not really going to do much. In terms of the engine, all it really has to do is call a very specific GLFW function. This GLFW poll events. And what this is going to do is it's going to actually allow GLFW to handle all of the events that are stacking up in the queue. So, for example, if I move my mouse or if I drag the screen around, this is going to allow those events to be processed by a GLFW and actually taken care of for us. So if we don't have this, we won't be able to like move our screen around or really take care of any events that GLFW receives. So we need that in there. And finally, we need our render function. So engine render. Now this one, we do a little bit of setup again. So again, I was talking about the double buffer thing here, right? So what we want to do is set up our buffer. Again, every time you render, you're currently rendering to the back buffer until you call swap buffers. And when you call swap buffers, that back buffer becomes the front buffer, and that's what the user sees. So as you can imagine, as soon as we do a swap, whatever the user was seeing last frame is now going to be saved in our back buffer, and we're still going to be using that old data. And we don't want to draw on top of old buffers. So the first thing we want to do is clear the entire buffer. So there's a function for that, GL clear color. So we can clear the entire buffer given a specific color. So let's do blue. So we'll do a 0, and these are values from 0 to 1. So 0, 1, 0, and alpha we'll just do 1. So now we've cleared our back buffer with a blue color, and because we're doing depth, we also need to clear our what's called depth buffer bit, and this is just a way for GL, basically OpenGL, to clear the bits that it uses for keeping track of the colors and the depths of our current screen. So we're going to do GL clear, and we're going to pass in, so this is a bit field mask, so we OR things together, and that's what we pass through. So we're going to clear GL color buffer bit, yep, this guy, oops, buffer bit, and then we OR things together. So we OR, this is bitwise OR, not like OR, this is bitwise OR, so we're creating a new, basically, integer, which is a mask based on what we want to clear here. So we're going to clear the buffer bit, and we're going to clear the depth bit, depth buffer bit. There we go. So we're going to clear those two, set up their clear color. So we set up our clear color, and then we actually go ahead and clear the buffer and the color and the depth. And once we've done that, we can actually go ahead and really we have nothing to draw right now, so we're just going to go ahead and swap our buffers. So GLFW swap buffers, you can call that, and you pass in our window. And that's pretty much it. So in here, anything that gets drawn in here, we'll actually be able to see. Anything that gets drawn outside of this, after we swap the buffers, anything we draw in here will never be seen by human eyes because we've already swapped our buffers. Anything we draw after that is just going to get replaced when our code comes back up here and clears everything up again. So if we want to draw anything in our entire game, it needs to happen between these things here. But for now, there's nothing to draw. So let's save that. And that should be the bulk of our engine code in terms of setting up drawing, what you're going to see, everything like that. So let me just check comments real quick to see if anybody has any issues, and it doesn't look like it. So again, if you have anything you don't understand, just feel free, or if you're following along, by all means, if you run into any issues, just let me know. So there's nobody there, so we should be good to continue. So we'll go back to Twitch, and we'll do hello Twitch, that's fine. And then we're going to get rid of our system pause, because now we're actually going to start using our engine. So first we need to include it, and I like to group these together. So we're going to include our engine.h. And now that we've included it, we can actually create our engine object. So engine, we'll call it engine. Okay. And when you do that, again, engine is just constructed at this point, so the constructor is executed. And now we can go ahead and basically set up a while loop. So there's something when you talk about games, you're talking about something that's called a game loop, and that's basically something that's going to be set up, and it's going to iterate through everything that we have in our game and update. So basically, call its update method. Any separated item or thing or whatever, sprite really, is going to get called update on, and then we're going to call render on it as well. Right now we only have our engine, so we're going to call our engine.update and our engine.render. Now obviously this is only going to happen once, so we want to put that in a loop. So let's say while true, and yes, while true, just for now, just to make sure that this is all working. So while true is an infinite loop that's going to update our engine and then render it. So again, update is just going to make sure that we can pull those events so that we can move the screen around. Render is going to make sure that we clear that back buffer, draw basically empty clear color to it, and then swap our buffer so our view will always get updated. So moment of truth, let's run this and make sure we're on 32-bit here. I'm going to go ahead and run it. And hopefully we don't run into any nasty issues. And look at that, hello Twitch. And we should see a screen soon, hopefully. Oh, so yeah, we're not going to see anything. We're stuck in a loop, but it doesn't really matter because engine never got initialized, so our Windows is useless. There's nothing there. So we're going to call engine.initialize. That would help, right? And we've already set up our width and height in the engine itself. We could change that so that we pass it in through here as well if we want to have a little bit more flexibility, which actually we probably should, but for the sake of this project, we should be okay. So we're going to go ahead and pass in a window title, and we'll say Twitch. And exclamation mark, yep. Okay, so now initialize is going to get called. Everything's going to set up properly. Then we can go in our infinite loop and update and render our engine. So let's run this, and there it is. Oh, and this is green, not blue. I must have messed up the numbers, but look at that. A screen is, oh, this is GLFW running OpenGL, clearing our back color to green, and pulling the event so we can drag this around. Notice that if I hit X, nothing happens. That's because that's a specific event we have to handle ourselves, because we may want to make sure that we deconstruct stuff or make sure we do some cleanup before we actually allow the user to just end the program. So this is something we're going to have to cover ourselves. But there's the big one, and now, funny thing about this, when you make this big, there is a callback that we can set up so that we actually do some resizing of our viewport, because right now our viewport is this size. So if we make this big, our viewport's only going to go up to about here. So anything we draw is just going to be here, and the rest is just going to be empty green space. But we'll get into that later when we actually have stuff to show. And obviously minimizes our game, and there we go. All right, so we've got something coming up. So GLFW is set up properly, which is great. So we'll go ahead and close this. And okay, great. So let me just check the comments again, make sure everybody's okay. Yeah. Oh, and by the way, I've got a very early version of some sort of Twitch bot that I have set up right now. It doesn't do anything other than allow you to check how many lane ads you have. Now that's just my currency name. I mean, it's just my name backwards, Daniel. So we can change the name. It doesn't really matter. But if you type !! lane ads, and apparently my bot is broken, and it doesn't look like it is, but it probably is. So there you go. I have some work to do on that side as well. But basically hoping to get some sort of bot up so that we can have a little bit more fun and allow for votes or other things like that. And the main thing really is so that you guys can give feedback through there, so I can handle that and receive your feedback properly on my PC directly instead of having to go through like Twitch's PM system. But for now, that's what we'll have to deal with. So okay, if everyone's good, then I will continue. We have our engine set up. Now, what we like to see is stuff showing up on the screen. So what we can do is set up a sprite. Now, sprite is basically your standard game term for some image that is shown on the screen at some point. Now, for For OpenGL, when we do sprites, there's a library called Soil, which is simple OpenGL image library, something like that. And it's basically a really easy way to let us actually load PNGs and other JPEGs, whatever, other images into our project using OpenGL. OpenGL has a thing, something called GL texture, which is how it handles its textures and drawing the textures and everything. So we're going to use Soil so we can set up OpenGL textures that we can then draw onto our screen. So this is going to begin by us creating a new folder within our engine called graphics. And within here, we'll create, what do we create? We'll create a texture object. We're going to do two things here. We're going to have a texture object, which is what Soil gives us back. And then we're going to create our sprite object, which has a texture object. And the reason we do that is because texture should really only focus with the data relating to the textures we're going to draw on screen. And sprite is taking that texture and placing it somewhere, keeping track of its position, of its rotation, of its scaling, all that stuff should be handled by the sprite itself. So let's create the texture first. Texture, CPP, and item texture.h. Okay, and again, .h likes to add the pragma once, so we'll go if def twitch underscore texture, define it, oops, and diff. Okay, class texture, public, private. This is basically how I start all my classes. Like my header file, set this up, and then set up my class public, private, and then I'm good to go. Okay, so the first thing we want to do is now here, because we're going to be using GLFW stuff in here as well, or OpenGL stuff in here. So we want to include that as well here. So GLFW, GLFW3, and now we need the Soil library. Now Soil isn't actually in like Nupin, or sorry, in NuGet at all. So we're going to need to actually copy that into our project. And Soil is something you can easily download, but I've got it somewhere in here. So I'm going to put it in Twitch engine graphics. I'm going to put it right here. This is where I'm going to put Soil. So I'm going to grab Soil from one of my many other projects that use it. Programming, C++. Let's see. Tanks. Oops. Nope. Tanks, engine, graphics, Soil. There it is. So I'm going to pull Soil in here. And again, you can just download that. Just look up Soil. It's a free download. And you'll be able to just drop that in here. And basically, this has both the lib and the source. So all the source. The reason we want the source is we want this header here. And the lib is the lib we're going to point to. Libs, soil.lib. Okay? So we've got lib, we've got Soil. And if you want, I can post a download link to that after this as well. Now what we're going to do is, again, this is going to show us what's in our project right now. So we can refresh and you'll see that Soil shows up magically. Again, this shows up what's actually in Explorer. So this is what we want. Now in lib, we want to make sure we include soil.lib into our project. Oh, here we go. So we're going to include in project, and that's going to basically allow us to use this lib directly without having to like pragma comment it or anything. And then source, we have everything here. Okay. So everything is within this graphics folder, meaning that texture should be able to include it like this: soil, source, soil.h. Okay. Now we've got access to the Soil library. We've included the lib in the project here, which means it'll get compiled with everything else, meaning we should be able to just go ahead and use it. So in here, in the texture, what we want is basically we'll have our texture. Oops. Texture. Now there's going to be a couple ways we can do this. We'll just set this up, I guess, for now. But we also want to be able to. So we like having basically constructors that take nothing in. So that we can create these objects like in arrays and vectors and all that kind of stuff. So we can do this. We'll also say texture taking an int ID, and then I'll do underscore ID because I'm going to keep track of this afterwards as well. And texture, and we'll pass in a string path. Now for this, let's actually use IOStream or sorry, string, like the STL string. So include string using namespace cd, and we're probably going to be printing stuff out too, so iostream in there as well. So we'll take in three, so these are three overloaded constructors, taking in, one takes nothing, one takes an ID, and one takes a path. And then we'll basically keep track of these pieces of data as well down here. So we'll have our int ID, our int, now our path we don't really keep track of because once we load it, it's there, it's in memory, we don't really need our path anymore. But what we do want to keep track of are the width and height of the texture itself. So we'll take track of int width and int height. And there we go. And now we've got these, and now we can say it's get ID, just in case we ever need it. Create some getters here, get width, and get height. Okay. Now, if we go over here, again, the first thing we do in our texture here is we'll include texture.h. And we'll start off with our constructor. So texture. Again, we only want an empty constructor, default constructor, because we want to be able to create these objects or have these objects set up like in an array or a vector or whatever. So we need to have the empty constructors. So for now, we'll just set ID equal to -1. And this ID is what OpenGL tracks our texture as, which is why we need to keep track of it. This ID is what allows us to set our texture before we draw it. So OpenGL knows what data we want to actually draw to the screen. So this ID is very important. But again, for an empty constructor, we won't have anything in there. Texture, if we ever pass in an actual ID, then we'll just set our ID equal to this ID. Okay? And if we do texture, pass in a string path, then we actually need to do some work. Now, I like to put this actual soil work in its own function that is not publicly available. So I'll put it in here, and it's basically going to be return a bool. It's going to be load image, and this is going to actually load the image using the soil library and give us back that texture ID. So const, so we'll take a path, so we'll do const char star path, and this is because this is what soil likes, and then an unsigned int, call it flags. This is if we want to pass any flags at all. And so this is what we're going to create a function with here, and then we're going to go over here and actually implement that. So before we do anything in here, because we're actually using this path, and really this is how we're going to be loading our textures like 90% of the time, is with a path. So we'll give it a path to a PNG or something, and then we'll actually go ahead and use that. Let's do our texture load image, and we'll take in again that const char star path, unsigned int flags, and we can actually go ahead and encode this now. So soil, again, does all of the work for us. So all we have to do is set our ID equal to this, whatever this function returns. It's soil underscore load underscore OGL, OpenGL, underscore texture. So load a texture for OpenGL, and here's the path for it. And the flags we want to pass in, or sorry, not yet. These are the channels. So the channels, we basically just want soil to figure that out for us. So soil load auto, it'll just do it automatically. Our reuse texture ID is, well, we're not reusing any IDs. We want to actually create a new one. So what we can use here is soil underscore create new ID. There it is. And now our flags, we can pass in our flags. Now this obviously may or may not work. If it does work, our ID will be something greater than 0. So if we wrap that, if ID is greater than 0, then we can actually go ahead and set up our width and height that we can pull from the image. And our width and height are just good information to have based on the texture. And that's really all we care about in terms of texture. We want the ID that OpenGL uses to track it, and we want the width and height just so we know, like, if we want to resize it or whatever when it comes to actually using these textures. So what we want to do here is set up what's called our MIP level, MIP level, set it equal to 0. And this is just the higher the number, it's like I think this has to do with compression. I'm not 100% sure what that does, but it's basically used when we get parameters from GL itself. So every time we want to use a texture, again, soil already loaded our texture and gave us an ID, and it dealt with GL directly, and it told GL, hey, I've got this texture that is this data, and it's going to be referenced with this ID. So now that OpenGL knows that, again, soil did all the work for us, what we want to do is before we try to get parameters from this texture, which are going to be the width and the height, we're going to have to let OpenGL know which texture we're referring to. And this is what I mean by we have to track these IDs. We're going to call this GL bind texture. And we pass in a target and a texture. So our target is what GL target we want to bind the texture to. So we're going to do GL texture 2D. So that's what we want to bind it to. And what we're actually binding is a very specific texture. It's our ID. And this is, again, how OpenGL tracks your textures that we loaded from soil. So now that we've bound our ID to GL texture 2D, we can actually get parameters back from it. So we can say GL get text, this is texture, level parameter, and we'll do int instead of floats, so IV. And again, we're pulling them from the target, which is GL texture 2D. And the level is going to be the MIP level, which, again, that we just use 0. And then the name we want to give, parameter we want to pull, given a name, is going to be GL texture, and then we have width, there we go. And we want it to store it, and again, it takes a pointer to a GL int, or just a regular int, we can cast that. So we're just going to give it a reference to width, just like that. And then we're going to do the same thing for GL texture height, and we're going to pass in our height, which again are member variables that we have in this class. So what we're doing here is loading the texture, giving it an ID that we keep track of, and if it's a valid texture, we're going to go ahead and set our MIP level, GL bind texture. We're going to bind our texture to GL texture 2D, so we can reference it here when we get the parameters. And when we get the parameters, we want to pass in GL texture 2D, the MIP level, the width, this is what we're asking for, the parameter name is the texture width, and we're going to store it in this variable. Same with the height. And that's it. And then otherwise, and if basically ID is less than or equal to 0, something went wrong. But again, all that we want to do here is load the image, or at least try to. We return a bool for a very specific reason, right? If this all works, we can return true, and we're good to go. Otherwise, we'll just return false, and we'll let somebody else deal with the error handling. Again, this is just loading the image code. So now that we've got this private function that we have here, we can implement these as well. But basically, this is the case we want to care about, right? So again, if we already had an ID and we just want to create another texture object that has the same ID for whatever reason, we just ask for a very specific ID and we give it the ID that we care about. So if we have a texture, we're creating a new one, and we just want to use it to track the ID, then we get that. We set that up perfectly. Now while we're up here, again, we can set the ID, but the width and height aren't going to be set to anything. So we basically want to do this exact same code here. And now copy and pasting code is not great, but because this is never really going to change, I don't feel too bad doing it, although really I should. That we could have this as its own function and then load images calls this, or we can even just do this within here. Actually, you know what? There's probably a better way to do it because I really don't like copying and pasting this code. So what we're going to do instead is this is going to move to here because this is only going to happen when we've actually got a path. Now we could actually take const.char path here as well, or we can just say path.cstr and pass that through. And then we don't have any flags, but basically the only flag we really care about, which you can also add in here, is soil flag multiply alpha. So this is going to say any alpha is going to be multiplied to the actual color. So if alpha is 0, that color is going to become 0, it's going to be empty. This basically allows us to have alpha. So we're going to multiply alpha there. We're going to call that, and then we're going to say if ID is greater than 0, then we can actually go ahead and say, and let's rename this then if we're going to change this. Instead of loading the image here, we're going to get image params, or get texture params. Let's do that. And we'll do get texture params, doesn't take anything, and we'll call this, because again, these pieces of information we've already, the flags, that's all really we need, and the path is getting passed in through here. So this we're going to call get texture params, and again, it's a private function, and then we'll do this, and I guess we can have that check in here. Return false if it couldn't because the ID is improper. Yeah, I think I'm okay with that. So then instead of checking it here, we just make that call. So if get texture params is false, and then something went wrong, and we can go ahead and say error. Yeah, but yeah, this is fine. This is fine. because I was going to say, like, if this really needs to be encapsulated within our error check as well, but it is because we use ID in here. So that should be okay. So cout error loading image, and we'll just give them a path as well so they know exactly what's wrong. Path handle, and then that's actually it for that. And so now by doing that, we can actually do that up here as well. So this is regardless of where we load it. All right, in this way we don't have an image, so we'll just say error loading image with ID, and we'll just pass the ID. ID. Perfect. Okay, yeah, I think I like this better. So now this is just getting the texture params that either can or cannot do it. If it can't, we'll do this. Otherwise, ID, width, and height will be set up in both cases. Yeah, that looks pretty good. So that's pretty much it. I guess we have to create those getters. So these are int texture, get ID, return ID, and then int texture get width, return width, and then int texture get height, return height. Oops. Return height. There we go. Okay, so the texture is good. Everything here is satisfied, so we should be good to go. So now that we've got our texture class, we can actually go ahead and create our sprite class. And our sprite class is going to have a texture, and it's going to keep track of this texture, which again has its ID that we can access, and it's also going to keep track of the positioning that we want that within our game. So let's go ahead and add sprite.cpp, and let's add sprite.h. Okay, and again, if and def Twitch sprite, we'll go define sprite, and if sprite public private. Perfect. So we have a sprite class in our .h, and again, sprite is going to be using GLFW, GLFW3. It's going to be using our texture, that class that we just created, so we'll include that as well. And we're probably again going to be outputting stuff to the console from here as well, so we'll include IOStream here as well. User namespace std. Okay. All right, perfect. So again, just like we did in Sprite, we're going to want default constructor, so Sprite nothing. Then we'll do Sprite, and we'll pass in a texture, and then we'll do, or actually, we either pass in a texture. So we can do this two ways, right? When we set up our Sprite, we either give it a texture we've already created ourselves, or we give it a path, and the Sprite will handle dealing with our texture. Maybe that's better. There's no point really in getting the game code to create a texture that's then just going to be passed onto a Sprite. So instead, what we're going to do here is we'll pass in, we'll include string, and we'll pass in a string with the image path, call it. And now again, our Sprite, what are we going to keep track of here really? We're going to keep track of a couple of things. Really, our texture that we're going to be using is just an instance of the object that we just created, of the class that we just created, and then we'll give it a position. So we'll keep that in float, I guess makes more sense. So start pause, or I guess we'll call it x pause and y pause. So we can have an empty constructor, a constructor that takes the image, and we'll just give it a 0, 0 pause. Or we can do sprite string image path, and then int, or sorry, float underscore x pause, float underscore y pause. Okay, so this way we can initialize the position for it. And yeah, that looks pretty good. So we'll have those three. Let's save that, and let's go to here. Again, we'll include our sprite.h. And here's where we're actually going to start doing real work. So our sprite, we'll start with our empty constructor, takes nothing. All we want to do here, I guess, is set the x pause to 0, y pause 0, and our texture, I guess, is uninitialized because we're not giving it anything. So texture equals texture, and we'll pass nothing through, which technically is already done just by virtue of the fact that this is set up here. But I like to just be specific here, just set it up to basically the empty constructor equivalent of a texture. That's pretty much all we care about there. Now, when we're actually passing in, oops, Sprite string image path, this is where we can actually do some work, right? So our texture will be equal to texture when we pass in, as you can see here, we pass in std string path, image path, right? So we can do that, and then we will set, I guess, our xpos, again, our ypos to 0, so xpos equals 0, ypos equals 0, and then sprite string image path, float underscore xpos, float underscore ypos. If we do this, then we can just do the same thing we did here, pretty much, except this becomes underscore xpos, and this becomes underscore ypos. Okay, so there we have our 3 constructors. This is, again, so we can have it in vectors or whatever, and then we can always add to it later. This is so we can add our image, and then we'll just give it a default position, and if we actually want to specify the position, then we'll set it up this way. So that's pretty much it for those 3. Now we can, again, every kind of object we have in our game needs to have 2 functions. So we'll have our void update and our void render. Okay. So that's now let's start with the update. Update is really for now going to be nothing because we have no way of like actually handling input or anything like that. So what we can do for the update is just do nothing, I guess. Sprite update. We'll do nothing in there. What's wrong with that? Oh, yeah, void. Really, our render is what we're going to work on today. So void sprite render, and here we're going to actually render our texture using OpenGL code. So here we're going to first thing we're going to do is, because we're not really aware or sure of what the state may be like when it comes to OpenGL, because again, it's a state machine, right? If somewhere else in the code I did something that changed the state machine, I can't have any expectations of what that state machine is going to be at when we're actually rendering. So we need to do all sorts of things. First thing we're going to do is GL enable GL texture 2D. Okay, oops, Jesus, I want to do that. Okay, so we'll enable our texture 2D. Then we're going to, again, we have that texture ID, just like we did in our texture here. We need to bind the texture ID to texture 2D. So when we do that, here, GL bind texture to GL texture 2D, we're going to bind our texture's ID. Now again, we have texture.get ID, we can call, get ID. Okay, so we're going to bind this ID to the GL texture 2D. And again, we shouldn't be calling render if none of this happened, because this is going to be equal to something. So texture.getID, and if that's a -1, then that's another issue. So now that we've done that, again, the first thing we want to do before we move the camera, rotate, anything like that, is load that identity matrix. So we know we're starting fresh. Nothing has happened to the identity matrix itself, the camera's matrix. So what we want to do, and the way we should be doing these things in terms of OpenGL, is there's a specific order in which we want to change what we want to do. So we load a matrix, load the identity matrix, then we basically execute translations on that matrix, then rotations, and then scales. That's just the way you have to do it for the math to work out. So again, it's translate, then rotate, then scale. Okay? So we don't have rotation or scaling implemented right now, so we're just going to handle translating, which is GL translate F, and we're going to translate it given an X, a Y, and a Z. So the X is our XPOS, our Y is our YPOS, and our Z, we'll just say 0 for now. We're basically always going to have a Z of 0, because again, we're in 2D. So we'll translate XPOS, YPOS, then we don't rotate, this is where we do GL rotate, and this is where we do GL scale F, I think, rotate F, scale F, but we don't have that yet, so we're just going to translate. Now we're actually going to render. So this is the real rendering code. And the way we're going to render is first we're going to set up a color for this sprite. Now obviously the sprite itself already has a color, right? It's whatever color the sprite has. But we can always add color to it and color it in a different way. So for example, if we had a white sprite, we could change the color here and it would be whatever color we wanted. But if we had like a black sprite, it doesn't matter what color we set it to because it's going to be different anyways. It's going to be black anyways, regardless of what tinting we give it. So if we just want the true asset color, we'll just set our color to white. And again, we have to do this because we don't know who set the color last time, and we don't know what the color is currently set to. So we need to say color 4F, and we'll do 4F because we do have the ability to do alpha here. But again, we're just going to do full alpha for now, just because we don't really have any way of tracking the current alpha yet. And I'm talking about the alpha of the sprite itself, the entire image, not the alpha that you get from the image itself. Like if the image has alpha, it's going to draw with the alpha because we've set those up in the flags. This is talking like I can decide to draw an image at 50 alpha, and whatever is actually on the image will be drawn at 50 alpha. But for now, again, we're just going to do white and full alpha. So everything once. And now we can actually call GL begin. And this is going to begin rendering, and we need to give it a mode of rendering. And because we're dealing with 2D sprites, they're usually just quads. So we're going to use GL_quads. Now that we've got this set up, we want to do a function that's basically GL text coord. So text GL texture coordinate, and because we're dealing with 2D textures, we only have two coordinates, and F because we're going to deal with floats. So GL text coord 2F. Now we give it the text coordinate. Again, this is a state machine, so we got to set the text coordinate we want from the texture. So if we're going to start at the top left or bottom left or whatever, we'll start at 0, 0. Okay? And texture coordinates are basically percentages. They go from 0 to 1. So if we wanted to start at like halfway through the image, we'll put 0.5. But because we wanted to draw the entire image, we'll start at 0, 0. And then we'll call GL vertex 2F. So we're gonna set up a vertex in our actual scene here. And again, because we've binded our texture, this is what it's gonna draw, given the vertices we're gonna give it. And because we're drawing them as quads, it's gonna go 1, 2, 3, 4 for all corners, and then we're gonna be good to go. So the GL vertex 2F we want to give it here is really just a position X and Y. So we want to draw the top left of the image, 0, 0. I think for images is top left, right? So we'll draw, or it might be bottom left. In fact, it is bottom left. Yeah, 0, 0 is bottom left when you're dealing with textures like this. So we want to draw the bottom left. So this is basically a way that we can set our centering for our image, right? So if we want to have the center position be in the middle of the image, we got to do some math in terms of the width and the height. For now, for simplicity's sake, let's just use the XPOS and YPOS. So if the XPOS is 0, 0 and the X and Y are 0, 0, then it should be drawn at the bottom left, but we should be able to see it. So this will be XPOS, wherever it may be, and YPOS. Okay. Now, sometimes these two lines, they get put on the same line because they really do the same thing. Or they're handling the same data. So we're going bottom left of the texture, we're going to put it at our current X and Y position. So we'll take that. So we start at the bottom left, then we'll go to the right. So 1, 0. So again, 100% to the right of the image, and still at 0% of the height of the image. So we're going to be at the bottom right corner. I'm going to put that, again, XPOS is correct, but we got to add that width to it, right? So let's say we'll add our texture.getWidth. And our YPOS will stay the same because we're still referencing the bottom of the image. That's why it's 0. Okay? So now we'll go the next vertex, and the ordering actually does matter. We're going counterclockwise here. So 0, 0, 1, 0, then 1, 1 is the top right of our image. So if you probably guessed already, we're going to add the width to our texture, to our position, and we're also going to add the texture.getHeight. We're going to add the width, and we're going to add the height. And I don't know why that's space there. And then finally, we're going to do what the only one that's left. So it's going to be 0, 1, and that is the leftmost side and the top side. So that's what we're going to do there. XPOS and then YPOS plus the height. So if this doesn't really make sense, I can try to explain a little bit further, but this is basically taking each corner of the texture and putting it somewhere in our scene, given our XPOS and YPOS. Now, I'm just realizing something now. Because we translated our entire matrix to this position, these should actually be zeros. So if we hadn't translated this, this would work. But because if we ever going to want to add like rotation and scaling that actually makes sense, we translate the entire matrix first. So we translate this. So if we translate this to like 100, and then we're going to set this to 100, this is from the point at which we've already translated to. So this would really be 200 in the global positioning. So really, let's go ahead and change these to zeros. And again, the y pos, we're already moved there, so the y pos is also 0. So here, instead of 0 plus, we can just do the width. And here, again, we can just do the height. So we don't want to add the y pauses here anymore. This becomes 0 instead. So we go 0, 0 is 0, 0, 1, 0 is the width and 0. 1, 1 is the width and the height, and then 0, 1 is 0 and the height. So there, we've set up our texture coordinates with our real scene coordinates, and now we can call GL end, and this will end our drawing. Oh geez, what did I do? There we go. This will end our drawing. So again, it's a state machine, right? So once we've begun, we need to end before we can continue doing anything else. So now that we've ended, again, we enabled GL texture 2D, but we don't want to get in anybody else's way in case they forgot to disable or enable whatever they need. So we're going to disable GL texture 2D. Oops, texture 2D. Okay. So now we're rendering. This code should take the texture positionings and put them wherever we translated our matrix to, and then it should actually render out. Now, there's two more things we need to do. One is our engine, its render currently does everything in one function. And again, like I said, if we want anything to show up on the screen, we need to write it in here. We need to have it in here after we clear, but before we swap buffers. Now, there's a couple different ways we can solve the problem, but just for simplicity's sake today, what I'm going to do is just create a begin render and an end render function. So this will be begin render, and we're just going to do the clearing, because again, the engine doesn't have anything to draw. It just needs to handle clearing and swapping the buffers for us. And then we'll go void engine end render, and then we'll swap the buffers when we call end render. So now that we've got that in our Twitch, instead of having render, we need to have begin render and end render. Okay, so the other thing we need to do is, first of all, include our engine graphics sprite.h, because Sprite handles the texture for us. We only have to deal with sprites. So then we have the engine there, and then we'll set up our sprite. So sprite test sprite, and we'll set it equal to sprite, and then we'll pass in a path. So the second thing I was talking about is we actually need a sprite to use here. So I'm just going to pull one real quick from OpenGameArt. If you've never used OpenGameArt, it's a place where you can go ahead and use free art that includes music, assets, anything. So let's look for like, let's look for a plane. This be whatever you want, and I guess I don't know why these aren't loading properly or something like that, but I want a plane. I just want like something simple like this. I think this is, oh, it's OBJ. Oh, this is 3D stuff. No, I want 2D art. Let's remove 3D. That should be fine. Oh, we don't want any music or documents or sound effects. We don't want textures. I don't care if it's concept art. Animated plane. I just want one sprite. Red biplane. Let's see what that is. It's a PNG. It's probably a sprite sheet, to be honest. Okay, that's not bad. Okay, let's use that. So let's save this. I don't know if you can do that. Let's just download it again, and we'll save it to our OneDrive. Projects, Twitch. Now here we can create a new folder. Let's create a new folder called assets, and then art, and then here we can just call it biplane.ping. And then we've saved it, and again, if we go here and we refresh, there's our assets folder with our art, and there's our biplane.ping. So we can pass this path through, and as you can see, it's in at the same level as our twitch.cpp. So I can actually go ahead and pass assets art biplane dot ping. And now that I passed this in, we have our test sprite, and let's give it a position. So let's give it 100 and 100. So now we've got our test sprite. So again, the two things we do is we update everything. So test sprite dot update, and again, this doesn't really matter, but it doesn't do anything, right? But let's just have it there for in order to be consistent. And then between the begin render and the end render, we want to do test sprite dot render. And this should be all we need to do. Now I'm hoping this will work. I think we did everything correctly. So let's run it. Ooh, some warnings there. Oh, look at that. There it is. So a couple of things. Our art is flipped on the y-axis. I think this is a knock-on from when we multiply the alpha. The way it deals with the texture, I think it flips it, so we have to flip it back. But look at that, it's at 0, 0. Really, that's what our asset looks like, because it's pretty much here, right? So if this is the asset flipped on the y, this is the 0, 0, and it goes up this way. That's why we have so much space down here, right? Because it's compensating for the real top of the y, which is up here. So look at that, we've got a really big asset. I didn't realize how big that was, but now we've got an asset, our sprite, given a position. Also, I guess, yeah, it's offset by 100 and 100. Drawing in our engine. That's pretty cool. So let's go ahead and just change this real quick. Let's make it like -100 and -100. We should see a little bit more of the plane here. And yeah, there we go. So we kind of offset it now, so you can see it's 100 pixels to the left and 100 pixels down. You can see that over here. Okay, so that's pretty sweet. We got some decent engine work set up already. Obviously, we haven't gone into input or anything like that, but that's kind of where we're going to be heading in the future streams here. So let me just check the comments one last time, make sure everyone's okay. And yeah, I guess that's pretty much it for today, guys. So let me know again, and if you have any feedback, or if anything, if you enjoyed it, if what you liked, what you didn't like, if let me know how it went, because I really want to make sure that this is something that we can all enjoy. And if you have any ideas of what you want to do, just let me know. Send me a PM on Twitch or on Twitter or on Reddit too. I'm on there as well, and we'll get going. So next time we'll probably take a look at fixing this and dealing with input, so we can actually move this guy around. Or maybe we'll make our own assets for that. I don't know. We'll take a look. All right. So that's pretty much it for the stream, guys. Thanks for coming out. I enjoy having you guys. And until next time, I'm pretty much going to try to do these on a weekly basis. So just keep checking my Twitch. I'll probably post another date. It might not be able to be Tuesday again next week, but I'll be able to do Wednesday. It'll generally either be a Tuesday or a Wednesday every week. So that's pretty much it, guys.